Hi there. Thank you for clicking on this video. This is our practice set for rational exponents. Please like and subscribe if you find this practice set video helpful. Drop a comment or ask a question to engage, and please check out the other videos and playlists on the channel. Without further ado, let's get into this brief practice set. Pause the video to work these problems on your own, and then come back and check your work. For numbers 1 through 5, you're going to be changing the radical to an exponent. For numbers 6 through 8, changing the exponent to a radical. And for numbers 9 and 10, simplify without using a calculator. Great. Now, these, like I said, this is a very short presentation. Normally, I break this up. We have like 1 or 2 problems per slide because there's a lot of work to show. There's actually no work to show for these. So this is really an honor system when your teacher gives you these problems, because could you like run them all through Photomath or Mathway or whatever and just write down the answers and nobody would know? Yes. Not going to help you. So hopefully you did work them out on your own and you're using this as a check. Now, here's our factoid that is so important, okay? Is that the nth root of x to the m is equal to x to the m over n, or again, that exponent could be on the outside. It would not matter. Both of those would end up as x to the m over n. And really, all this is about is relocating the numbers to the correct spot. Now, I'm going to say that number 1 is maybe the most important part of this lesson. When you're studying rational exponents and radicals, you do deal a lot with like your higher order radicals and kind of some messy looking stuff. But once you're out of the unit where you're studying it, typically the most common radical that you're ever going to see is a square root. It's just going to be the most common one that shows up in like pre-calculus, calculus, whatnot. So if there's one thing you want to lock in your brain from this study, is this first problem here. Now remember, that is a square root, so you got a 2 as an index, and you do have an exponent of 1 on there. And so this is just a matter of rearranging the numbers to the correct location. So I've got the n value here is a 2. So the denominator of my fraction is going to be the 2. And my m value is a 1. So the numerator is going to be a 1. And there you go. The square root of x is equal to x to the 1/2. This is actually used a lot in calculus to rewrite your radicals as exponents so that you can apply some of the like derivative rules that work with exponents. This is like basically how you would navigate it. So the square root is equal to an exponent of 1/2. And that brings us to the second problem, which is the cube root of x. And again, you want to remember that this does have an exponent of 1 attached to it. And so we're just rewriting it. We're going to have x to the something over something, and you just need to place the 1 and the 3 in the correct spots. The index is always going to be in the denominator. So if the index was 3, the denominator will be 3, and then that puts the 1 in the numerator. So the cube root of x is equal to x to the 1/3. Next one, we have the cube root of x to the 5th. And so once again, we've got the index is going to go to the denominator, so that'll be the 3. And the exponent is what's the numerator, so that's the 5. And x to the 5/3. And last but not least, oh no, we have 2 more. We have the 4th root of x all to the 3rd. So this one is just bringing it to you in that other form there. So you've got the number, the exponent on the outside, but remember the index is always going to be in the denominator. So in this case, it'll be 4. And the exponent will be in the numerator, so 3/4. And now last but not least, we have the square root of x to the 3rd. And we do want to remember that, again, the index on that square root is a 2. So when you go to rewrite it, the index will be the denominator and the exponent would be the numerator. Years and years and years ago, when I was teaching a lesson on this, I had a student raise his hand in class and say, so the smaller number always goes on top. And I thought, well, that's not what I said. I had given the class the same like kind of formula where like the index, like the n should match up with, but what I didn't realize was that every single one of my example problems, every single one of them, I had just picked a smaller number for the exponent than for the index. And so the student like accidentally drew the wrong conclusion because all my examples look the same way. And so ever since then, I've just been very intentional that when I'm doing this, like some of the fractions are what we call proper fractions, like 3/4, and some of them are improper fractions, like with the bigger numbers on top, just to make sure that I'm not accidentally making all my examples look the same way. And I always bring it up when I'm teaching now because it's a great example of why it's important to ask questions and even repeat back to your teacher your understanding of something because it was totally unintentional. I hadn't even realized that all my examples had done that. All right, next batch. Now these ones, we're going to write them as radicals. So we've got, again, our factoid. So the nth root of x to the m is equal to x to the m over n. And this time we're going in the other direction. So we have x to the 4/3, and we're going to rewrite that. The denominator is going to go in the index, and then the numerator is the exponent. Or you could write it as, you know, the cube root of x to the 4th, like whichever one you like. I usually go with the first one. I don't typically move the exponent outside the radical unless I have some reason like for why I want to do that. But it's completely up to you. Now we have x to the 1/4. So the denominator is going to be the index, and then the numerator is the exponent. And typically we would not write x to the 1st power. We would just simply say the 4th root of x, though you can put the 1 there. Not wrong to do it. And the last one, x to the 2/3. So the denominator is going to be the index, and then the numerator is going to be the exponent. Or if it warms your heart and makes you feel better, you can put the exponent on the outside, whichever way you prefer. So again, not a lot, like no work to show. It's really just making sure that those numbers get in the right places. Okay, now these last two were about doing this without using a calculator. So for number 9, most of us do not know 16 to the 3rd power. Okay, I do not know that off the top of my head. I think I can make a good guess at it because I just did the lesson. So I just had the 16 to, you know what? I have no idea what that number is. And I'm not going to, because I'm not going to go that way. I am going to rewrite that as the square root of 16 all to the 3rd. And I do know the square root of 16. The square root of 16 is 4. And so this becomes 4 to the 3rd. Do not say 12, okay? It's 4 times 4 times 4. 4 times 4 is 16. And 16 times 4 is 64. That perfect cube is one that you might know. Now, you might not know it, but even if you don't know it, you do 4 times 4 times 4. So you end up with 16 times 4. I'm in the upper right corner of your screen there. And hopefully you can do that and get the 64 without a calculator. Next one, we have the cube root of 27 squared. Well, I do not know 27 squared. And even if I did, I would not know how to take the cube root of it without a calculator. And so we're going to use the same little trick here. We're going to move that squared to the outside. Now, the cube root of 27, I actually do know. That is 3, because 3 times 3 times 3 does give you 27. And then now it's just 3 squared, which is 9. Now, the only thing I feel like I haven't really covered in this lesson is if you're doing like converting it over and you have more than one thing. I'll try to pick that up in a future video, but there we go. That basically is your introduction to rational exponents. Please don't forget to like and subscribe if you found this video helpful. Drop a comment or a question below and check out the many other videos and playlists on the channel. I will link something in the space below so that you can check that out. I don't know if I'll link a playlist, a short, who knows? Just click on it, find out what it is. It's like a surprise, a Jack in the Box kind of surprise. All right. Thank you for clicking again, and I hope to see you in a future video.